All right, more with slope, unit rate, rate of change. We're going to start off with a true or false. Rate of change means the same thing as unit rate and slope. This is true. All of these, rate of change, unit rate, and slope, all mean the exact same change. So what is the rate of change of the zip line? What is my slope of this zip line? They mean the same thing. So we can use our multiple ways of finding slope, unit rate, rate of change. One, I see that I have the ordered pair 0, 250, and we know now that each ordered pair or coordinate has exactly one x and one y in it. And if you look, looks like it intersects nicely in the middle here, or it intersects nicely right there. You get to pick which dot. I like this one. So I see that is the ordered pair or coordinates 150, and we have to pay attention to our intervals going up. It looks like each dash is worth 25. So 150, 225. And again, each coordinate or ordered pair has one x and one y. So I'm going to use my formula for finding slope that we learned in the beginning of the chapter. Change in y over change in x. And I see I have negative 25 over 150. And we will have to reduce this fraction. So it is negative because it's going downhill. And when you reduce fractions, right, 25 goes into 156 times. 25 goes into 25 once. So you get a slope of negative 1/6. Or we can create our slope triangle right here. There's my triangle. I went down. My rise is negative 25 because you see that each interval is worth 25. And then my run, pay attention to your intervals again, is 150. So again, negative 1/6. When reduced, remember to always reduce and keep it a fraction. If it is improper, leave it improper. So rate of change of the ramp or slope or unit rate here of my ramp of the back of this truck. So I can come up with my ordered pairs here. I have the ordered pair negative 4, 0. Each ordered pair coordinate has one x and one y. And I see I have the coordinate 0, 1. And this coordinate, like all coordinates, has one x and one y. And now I can use my formula. Change in y over change in x. So I should get 1/4, or I can create my slope triangle. And I rise 1, rise over run. I run 4, I went up, I went to the right. Both are positive, so I get a positive 1/4. What is the rate of change of the top of this truck, or what is the slope of the top of this truck? This line right here. So we can pick any 2 points. We can do rise over run, or we can do our change in y over change in x. Or if you know that all horizontal lines should have a slope of 0, let's prove it. Here I have the ordered pair, 0, 4, and like all ordered pairs, they have one x and one y. And here I have the ordered pair, 2, 4, and like all ordered pairs, it has one x and one y. And now I use my formula, 4 minus 4 over 2 minus 0. 4 minus 4 is 0, 2 minus 0 is 2, 2 divided by 0 is 0. Therefore, I am correct. So here, rate of change is the same as slope. So the letter that represents rate of change is also m, like we've been talking about. The formula for a line, this goes for any single line, any straight line, the formula in slope-intercept form is y equals mx plus b. This is a very important formula that we are going to get into. Y equals mx plus b. So notice that y is all by itself. The rate of change always goes in front of x. So see how m is right in front of x? So the rate of change will always be right in front of the x in this equation. So when y is by itself, the number in front of x, or the coefficient of x, will always be your rate of change. So if I had the equation y equals 1/4 x plus 6, I asked you to find the slope, unit rate, or rate of change, you should be able to tell me that m equals 1/4. That's it. So here, rate of change, same as slope. We have our two ways of finding this. Here's a point, here's a point. Let's find the ordered pairs. I have the coordinate 0. Every other goes by 1, so it's 0, 3, and each ordered pair has 1x and 1y. And then I have the point 2, 0. Each ordered pair has 1x, 1y. So I will do my change in y, which means to subtract my y values, over my change in x, which means to subtract my x values. Negative 3/2 is the slope there. Or I can use my slope triangle, where I go down 3. Down is a negative move, to the right 2. Oh. So I was not paying attention to the intervals. That is 1. So this just equals negative 3. As you can see, it's very easy to make a mistake. I was not paying attention. See how every other is worth 1? So this, I go to the right one. So negative 3 divided by 1, and I need to simplify that to be negative 3. So here, the two ways we can do this, you will have to graph these. Okay, these are just coordinates. That's all these are. And remember, each coordinate has 1x and 1y. 1x, 1y. So I can use my formula here, change in y, or subtract my y's, over change in x, which means to subtract my x's. I have 2/3 divided by 2. All right, which you can plug this into your calculator to help you, which equals 2/3 times 1/2, which equals 1/3. So my rate of change, or my slope, is 1/3. What is the rate of change of the equation? Again, we talked about this just a minute ago. When y is all by itself, which it is here, see how y has no numbers in front of it, which means there should be a 1 there, but you don't need to put that 1 there. So when y is isolated, the number or coefficient of x is your slope, or your rate of change, or your unit rate. So here my slope is 2/3. So here, the left column always, always, always represents your x. The right column always, always, always represents your y. So you can graph these if you want. That will take a little bit longer, but you can use your slope triangle to figure those out. Or we can use the coordinates. Our change in y means to subtract our y values over our change in x. So I started with 25 on top, which means I need to start with 0 on the bottom. 25 minus 22 is 3. 0 minus 1 is negative 1. 3 divided by negative 1 is negative 3. So that is my rate of change, slope, rate of the table. What is the rate of this table? Again, the left column is always x. The right column is always y. These are just coordinates where each coordinate has 1x and 1y. So to find my rate slope of the table, I am going to subtract my y values, change in y, over change in x, 11/2, and that is going to stay that way because that is reduced, and I am leaving it improper because when we get to graphing, you are going to want the fraction to help you with rise over run. So this is slope, unit rate, rate of change. Remember, they all mean the same thing, and you find them the exact same way.